At this time, we have learned everything that we possibly can about polynomials in itself. What exactly are they? All the vocabulary that's associated with them. How might we name them, or how might we classify them? So now it's time to start doing some actual operations with them. So in this video, we're going to be learning how do we add and how do we subtract polynomials. Before we actually get into any adding and subtracting polynomials, we kind of have to take a step back for a moment and learn a key process that goes along with it. And this process is combining like terms. Basically, when we add and subtract polynomials, all we do is combine like terms. So we have to clarify what are like terms exactly and how do we actually combine them in the first place. Hopefully you remember the definition of terms are the pieces separated by the plus and the minus signs. So for them to be like terms, they have to have the exact same variables with the exact same exponents in this example since we're dealing with polynomials. But eventually we'll see other versions of like terms, meaning again, exact same variables, but they might have to have the exact same exponents, radicals, or anything else similar to this. So, in example 1, we can see here that each of these terms are all like terms because they all have the x squared in them. So for us to combine these like terms, really we just need to combine the numbers in front. We need to do the operations that we see there. We need to take 8 and add it to 6 and then subtract this last term. Now, if there's no number or no coefficient associated with the term, it has an assumed coefficient of 1. So 8 plus 6 minus 1. And once we do that math and we attach the like term to it, that is how we combine like terms. So 8 plus 6 gives me 14. 14 minus 1 gives me 13. So this simplifies to be 13x squared. I combine the numbers, meaning I combine the coefficients in front, and then I just attach the like term, meaning the same variable, same exponents along with it. So my answer to example 1 is 13x squared. Example 2 is a little bit more difficult because there's lots more variables and there's lots more exponents to deal with. Just note that they all have to be exactly the same for it to be considered like term. So if I look at my first term here, I see that this guy has an a, b cubed. For it to be a like term of something else, it has to be exactly the same, a, b cubed. And if I'm looking through, I do see that I have that in a different term. So that means I need to combine their coefficients in front. I take my 1.2 and I subtract my 5.4. And once I do that math, that will combine these two like terms. So 1.2 minus 5.4 gives me negative 4.2. So in combining these like terms, I get negative 4.2 a cubed. Now let me look at my other pieces. So in my next guy, I have an a squared times b, and I want to see if I have any other like terms. Now my last guy is pretty similar. It has an a and a b and a squared in it, but notice in my pink or purple guy here, the squared goes over my b, but in my green highlight, I have my square over my a. So these are not like terms. I cannot combine them together because those are not exactly the same. So I just copy down what I have left because I can't do any combining. Negative 6.8 a squared b plus 2.3 a b squared. So the only like terms in this example were the circled ones here. And those were the only two that I can combine in this example. All right, now that we know the way to do this, let's see how we add and subtract polynomials. So I have two examples here. The first one is adding polynomials, and the second one is subtracting polynomials. And the trick to these is basically what we've just been discussing, combining like terms. So I suggest that you pause the video and see if you can do these operations on your own. So let's start with example 1. Notice that it is an addition symbol, but my first question is it actually has parentheses around my two polynomials. And I want to know if those parentheses are necessary to be there or if I can just ignore them or drop them. Now the reason that these parentheses are here is they are trying to tell you that this is our first polynomial plus our second polynomial. But if I think back to my rules of order or PEMDAS, they're not doing me any good in my rules of order type of stuff. This is all down to addition and subtraction, so it doesn't matter what order I do it in, I just need to work it left to right. Or we know that addition is commutative and associative, so actually the order doesn't matter what we need to do it in. So the only thing I really need to work here is picking out my like terms. So let me kind of erase all my scratch marks here and just note that the parentheses don't matter in this instance. So the first like terms that I see is negative 4p to the 7th and 2p to the 7th. Those both have a p to the 7th, so I add the numbers in front. Negative 4 plus 2 gives me a negative 2p to the 7th. Moving on, I want to continue to pick out like terms, but I also want to make sure that my answers are in descending order, because we know that polynomials should be in descending order. So I'm going to work this in descending order, picking out like terms. If I look at my next highest exponent, I see that that is negative 2p to the 4th. I don't see any other like terms with it, so I will just copy that down. My next highest exponent is negative 3p squared. I don't see any like terms with that, so I will just also copy that down. Next, I see that I have a negative 4p and a positive 4p. So these are like terms, but these actually end up canceling each other out. Negative 4 plus positive 4 gives me 0, and I could write plus 0p, but 0 times anything is just 0. So I don't need to put in extra things that aren't important, so I'm not going to put that in there. And last, I have my constant term of 7, no other constant terms to combine it to, so I also again just copy it down. So my final answer to this problem is negative 2p to the 7th minus 2p 4th minus 3p squared plus 7. I combine all of my like terms, and my final answer is in descending order. Now, in example 1, I said those parentheses don't do much for us, we can ignore them. In example 2, that's a completely different story. In example 2, it is a subtraction problem. And this subtraction is telling me that I want to subtract my whole second polynomial. If I just ignored those parentheses, it would look like this. Negative 2.6a squared b minus 4.1ab plus 2.1b squared. So if I ignore the parentheses, that's just saying that this negative is only going to the first term in that polynomial, which is not true. Remember that negative needs to go all the way through. So the easiest way to do this is to take this negative and turn it into a plus negative. Remember back to subtraction, a minus b is the same thing as a plus a negative b. So I'm going to change this as a plus here, but my negative, I'm going to distribute it through. So that means I change all of my signs in my second polynomial. So that gives me a negative 2.6a squared b. A negative times a negative 4.1 gives me a positive 4.1 AB. And negative, when I distribute it to my last term, gives me a negative 2.1b squared. So it changes all of my signs in the second polynomial. So the easiest thing to do is distribute that negative through. I have a lot of people try and skip this step and do it in your head, which theoretically should work. But what happens is people tend to lose their negatives, and then they end up with the wrong answer because of it. So I strongly suggest that you write this step out so you don't mentally lose negatives along the way. Now let me rewrite out my first polynomial here, and it does not matter whether I drop the parentheses of this because that was there just to hold the polynomial together. Okay, now let's start to pick out like terms. So I have a 6.1a squared b, and I combine that with a negative 2.6a squared b. 6.1 minus 2.6 gives me 3.5, and I attach my like term, a squared b. Next, I have a 2.9ab. I can combine that with a 4.1ab. That gives me a 7ab. And last, negative 4.5b squared plus a 2.1b squared gives me a negative 2.4b squared. So I've combined all my like terms, but before I box my answer, I want to make sure that it is in descending order, where my highest exponent is first and my lowest exponent is last. Now, this might not look like it up front, but it actually is. When I have two variables, like I do here, I have an a and a b, you want your first variable, alphabetical-wise, a, to be in descending order. And if I look at that, it is. I have a squared, I have a, and then I don't have any a's. So my a is actually in descending order. Now, if we can do it at the same time, not always, but if we can, then we want our second variable, which is b in this example, to be in ascending order. So we want it to be increasing rather than decreasing. So here I have 1b and 1b. Now that's not really in ascending order, but it's close. And then I have my b squared here. So at first glance, this might not look like it's in descending order, but I think it actually is in best order overall. So that's the way I'm going to box it and hand it in. Now sometimes if you have more than one variable, it's just impossible to put it in any good order. Just try your best and go with it. Both I and the homework will be accepting if there is no official best order of it. But if you can put it in descending order, then that is your best